Hello, everyone. Welcome to the last session today on application virtualization. I'm Elsie Nalipogu. I'm a program manager on the application virtualization team. We're actually located out in Boston. I'm joined by John Sheehan, who's an architect on the application virtualization team, and Alvin Chardon. He'll be coming up later on, and he's a tester on our team. So here's a quick run-through of the agenda for today. So I'll start by giving you just a very brief background on application virtualization, and then we'll go into some of the benefits of application virtualization. And the key thing we'll focus on is some of the scenarios that application virtualization enables. Then John will do a deep technical dive into the product, and after that we'll share some best practices, mostly around development, debugging, and testing your application. And finally, we will tell you how you can get the application virtualization client and how you can try it out right after we do the talk. So before I get into the talk, could I have a show of hands of how many people here have heard of application virtualization? Oh, wow. Wow, that's great. And how many people have heard of AppV or Microsoft AppV or SoftGrid? About roughly the same number of people. Yeah. Well, that's great. That's a lot more than we expected. Microsoft Application Virtualization, which from now on I'll refer to as AppV, it's been around for many years, and it's been a fairly niche product in the enterprise space. So that's why I was a little surprised to see that a lot of you knew what AppV was, and that's great. What we've started seeing just in the last few months is application virtualization is growing very rapidly in the enterprise space. And it's no longer the niche product that it was just a couple of years ago. And well, so what does that mean for you as developers? What it means is maybe a few months ago you wouldn't have heard of application virtualization or AppV, but now, as we hope that it becomes more mainstream, you're probably going to hear about this from your customers. And in this talk, we hope to tell you what AppV is, what are the key benefits and scenarios it enables, and also tell you how you can design your application so that it works well in a virtual environment. So before we go into AppV and how it works, I'd like to walk you through some of the key benefits of AppV, and in particular, I'd like to go through some of the key scenarios that it enables. So today, I know we had the keynote, and we heard a lot about software plus services. And I'm sure a lot of you have gone to different talks throughout the day, and you've heard software plus services over again. Some of you might even be thinking about rewriting your applications or thinking about how you can take advantage of this change. And this is where AppV comes in. You see, for many years, our enterprise customers have already been converting traditional applications to run as a service. And the reason they love doing that is they can repackage a traditional application, run it as a service without rewriting the application at all. So basically what they have, they use one of our tools, they repackage the application, and from there they create what we call an AppV application or a virtual application. You can take this virtual application, put it up, let's say, on a web server, or you could also put it up on any portable device like a USB key. And this allows you, just like with any other web application, to run it from pretty much anywhere. Just like web applications, some of the other new scenarios that AppV enables is if you can imagine a user clicking on an application and being able to run it right away. So today, when they click on an application, they have to wait, they have to go through a setup process that could take a lot of time, and then after that, they get to go and run the application. So in this new model with AppV, you can simply click on the application and run it. For developers, and a thing that I've heard very frequently in our team is when you first set up your machine, you have a number of different applications, right, that you want to set up and configure on your machine. And it probably takes you hours to install all those applications and get it just the way you need your development environment to be. And then if you try out a lot of new versions of software, or maybe you test out a lot of new versions of software, then you have to do this every single time, and it can take you a long time to configure your machine. All the developers and testers on our team love AppV because now they don't have to spend all of that time installing applications anymore. All the applications get delivered over the network onto the machines, and they click and they can run all their applications. Another key scenario that a lot of our enterprise customers love about AppVs is how easy it is to service. So today, a lot of enterprise managers, they have to go and they have to schedule downtime, and they have to plan deployments across thousands of machines and make sure all those machines are patched. With AppV, just like, again, with web applications, what they can do now is they update the AppV application just once on the server, and then all their users can get the latest version of the application automatically. Another key benefit of AppV is isolation. And in fact, most of you, when you hear the term application virtualization, that's probably what you already inferred. The thing about isolation is that it enables some very cool scenarios. The first one is you can run applications, 2 different versions of the same application. You can safely run those applications side by side. Now, what are some of the scenarios that might be interesting to you as developers? Well, think about this. Maybe you have some users that are on your old version of your software, and they're not quite ready to try out or release or let go of that old version and move to the new version. Well, what virtual applications allows them to do is they can go try out the new application or the new version without removing their old version, and they can safely run those side by side. What does that mean? I don't know how many of you write enterprise class applications? Oh, that's good. Looks like most of you. So for enterprise class applications, you all know that a lot of them can be very costly to deploy, and it probably takes enterprises like months to test those applications before they'll deploy them. And a lot of our enterprise customers have told us that now with AppV, it's much easier for them to deploy and much quicker for them to deploy products. And this is because now they no longer have to spend months testing that application, because with AppV, the applications are isolated, and you pretty much guarantee that the application doesn't make any damaging changes to the system. So for developers, that means you can get your customers, especially if they're enterprise customers, to deploy your product much faster than using natively installed applications. The other key thing that isolation enables is state separation. And what does that mean for you? Well, it means if you're trying to get an application that's truly a per-user application, that's what you can get. If you'd like to reliably have user settings roam with the user, you can get that as well with application virtualization. So with that, I'm not going to talk anymore. I won't spend any more time talking about the benefits of AppV. I'm going to hand it over to John, and John will show you a demo and show you exactly how AppV works, and then he'll do a deep dive.
Thanks, Elsie. How's everyone doing? Good? Long day, last presentation, want to get out of here? All right, well, hopefully you'll see a few things here that make it worth your while to stay around. All right, to the demo. So sometimes it's kind of hard to get people to understand the benefits and what AppV looks like to end users, because you're so used to your applications being installed on a system and really being tied to that one machine, and it's difficult to sort of think about a world where that's no longer the case. Your application can flow from machine to machine, over the network, over the internet, from devices. And so what we like to do is just sort of show people how it works. I need my lanyard. It has the USB stick in it. So I'm going to tap dance up here because my USB stick is in my lanyard, which will be brought up here in a minute. And basically what I'm going to show you is one scenario that sort of brings home the power of what we're talking about. And that is thank you, the case where I've taken Office and I've virtualized it and I've put it on this USB stick. So here I have my laptop. It doesn't have Office on it. So just to sort of demonstrate, I have a whole bunch of applications like our presentation, those kind of things. And if I double click on them, they can't run. And what I can do is if I have AppV, I can put the application on a USB stick and carry it with me. I can walk up to a machine that doesn't have Office, plug it in, and there you go. Now you have Office. Office is now on this machine. It behaves just like you would expect Office to. The file type associations work. The shortcuts all work. And that's it. It's there. And it's that simple. Normally, if you're going to install Office, you think about how long it takes. You have to go and you have to, get the installer, run it, wait for it to install. Office is good about not rebooting, but lots of applications require reboots. If there are any patches that have to be applied, those have to be patched and rebooted. But you don't run into those things with AppV because the application is separate from the operating system. And so here we go. So I just went ahead and installed Office in, 5 seconds or so. And the opposite is just as easy. If I go ahead and take the stick out, AppV will detect that the application's gone, and boom, it's gone. And that's it. That's how it works, literally. The key power here is that we're not changing the operating system. So every time you install an application, you're running an experiment. You're running an experiment where there's a bunch of code that some developer wrote that is going to go and change your operating system. It's going to change your registry, it's going to change your file system, it's going to change a whole bunch of shared resources. And you hope that when the experiment's done, your machine is still functional. How many people have ever installed a piece of software and then their machine wasn't quite the same ever again? Right? Everyone, right? It just happens, right? I mean, installers are extremely difficult to write. And the reason is because of the way Windows built. And with AppV, what we've done is we've said, yes, applications need to be built a certain way, but it doesn't necessarily mean that they have to change the operating system in order to operate. And so what I'm going to do now is I'm going to take you through, at a high level, how AppV works, and I'm going to try to drill down in a few details that should help you understand what we're really doing, right? Because that's great. That looks really cool, but what the hell just happened, right? It's very difficult to sort of to think about applications in this way when the operating system has never behaved this way before. So, see, that's the problem of having two machines. All right, so how does it work? This is just an introductory slide. Don't worry, I'm going to go through a few more slides and give you more detail than this because obviously this is just sort of the basic workflow. But the starting point for virtualizing an application is a tool that we call the sequencer. And the sequencer basically is a repackager. So if you guys have ever used Admin Studio or Wise or any of those kind of tools, it's a very similar kind of idea. The big difference is we're watching the changes to the system so that we can build up a package that we can then run as a virtual application later. And so, sequencing an application is pretty simple. You take off sequencer and you say, I want to create a new virtual application. You give it a name and you say go. And then all you do is just install the application however you normally would. Run an MSI, run a setup.exe, copy files, edit file, do whatever you would have to do to typically install the application. And when you're done, you tell our sequencer, I'm done, and that's it. We go ahead behind the scenes and we can basically build up the package, and now you have this single file, which granted is large because it contains all the resources of the application. But you have the single file that you can now put up on a server, and you can, and now all your users can immediately have access to it, or all an enterprise's users can immediately have access to it. And so this is very powerful for companies, and we're seeing huge uptake. If you saw that very early slide, we sell 1 million, 2 million, 3 million. We just keep selling millions and millions and millions of seats every month because companies can save tons of money by doing this. The streaming piece of it really is all about moving bits. So our streaming technology isn't particularly complicated. We actually support lots of different ways of streaming. You can stream over, we have a proprietary protocol. We can stream over HTTP. We can stream over SMB. And so it's just sort of, the streaming piece is really just getting the bits from the server to the client. And once those bits get there, the real magic comes when we start running the application. And I'm going to take you through a little bit about that. But the term that I'm going to keep using over and over and over again is virtual environment. And usually we use the metaphor of a bubble, right? So the application runs inside of a bubble. And inside that bubble, All the resources that the application had installed are there, and the application can see them and touch them and use them just like it normally would. Outside that bubble, meaning on your local system, those resources aren't there. And that's sort of the power of virtualization and how it works. So what are you really doing when you're virtualizing an application? What you're really doing is building up a list of all the resources that are needed to run that application, all the files and registry entries and COM objects and whatever else it is that make that application special. You're really just recording and building that up. And then you are putting it in a package, or we call it an image, that makes it easy to move that application around. As long as you can get access to that image and you have the AppV client, you have the application, you can run it. And that's really the key thing that you have to understand when you think about application virtualization. I have this here about optimizing for streaming. So over the network, so let's say over a LAN, an enterprise, they virtualize Office 2007. And it's about 2 gigabytes, because they put all the pieces of Office in there. And then they publish it on a server. A user can see the shortcut and immediately launch it. Right now, the user experience for getting Word up and running and ready to edit is about 7 to 10 seconds. So they go from nothing to Word running, and they can start typing in about 7 to 10 seconds. Well, obviously, we didn't move 2 gigabytes of data over the network in 7 to 10 seconds. What we're doing is this thing we call streaming. And streaming really is all about getting just the blocks of the files that are needed to run over the network quickly, getting them down on the machine so that the application can then start running. Behind the scenes, we can optionally trickle all the rest of the bits down, so that eventually the entire application gets there. But in the meantime, the user is using that application. And obviously, if they start using it, they may touch pieces of the application that aren't there yet. So, they open up Word, and the first thing they do is touch the equation editor because they're like a math guy or something. Well, we have a file system sitting underneath that can actually handle all of those requests. And effectively, what's happening is the system's in the middle of a page fault, and our file system handles the page fault because it's the file system for the application, and sends a quick request out over the network and says, "Get me this block." And so that way, even though that feature isn't there yet, we can very quickly get those little pieces that are needed to get that feature running, and do it in a way that the user doesn't really notice much of a lag. Sure, there's a little bit of a delay, because the blocks aren't there, so they have to come over the network. But users typically don't notice too much of a lag. There may be a little bit of choppiness or something. But the key thing is that only happens once. Once we get those blocks, they're stored on the machine. And I'll tell you right now, I run all my applications virtualized. I run multiple versions of Visual Studio and Office and everything. It's all virtual. And I got on a plane last night to come out here, and I'll tell you, if I didn't have my apps with me, it would have been a pretty bad flight, because that's the one time it's quiet and I can get some work done and not get 50 emails. And your users have the same needs, right? People have laptops. Laptops disconnect from the network. They go places. If those bits didn't go with them and they always had to be connected to the network, then it wouldn't be a particularly compelling technology. So, sorry, I'll move on to the next slide. So, how are we actually running applications? Like, what's happening on the client machine? So you get the idea, you get all the resources, you put them up on a server, you understand the bits can come down. But what's happening on the client machine in order to run that application? And what's happening is we're building up this thing called a virtual environment. And the virtual environment is all about taking those resources that were captured at sequencing time and making them available to the applications that are running inside this runtime environment. And so what that means is if I'm running winword.exe, winword.exe accesses lots of registry keys and lots of files that were installed by the Office installer. And if those things weren't there and it couldn't get access to them, and if it couldn't get access to them in exactly the same way it normally gets access to them, then the app would be unhappy, it would crash, and it would be dead. And so our virtualization layer is all about taking those resources and supplying them to the application as they're running. And The way it does it, it basically, if you think about it, you have your operating system. It has a file system, a registry, all those kind of things, and all the code that works to make those things available. And you have the application. And what AppV does is our virtualization layer sits in between. And all those OS calls first go to AppV. We look at the call, we figure out, is it looking for a virtual resource or is it looking for a native resource? If it's a virtual resource, we handle the request, we give the response to the application just like it would get if it was locally installed. If it's a native resource, we allow it through to the native system because those virtual applications still need to be able to see everything that's on the local system. So if there are some other components that are locally installed, the application can see those resources, see those components, access them just like it always would. Some of the tricky parts come when there's what's called conflict. So sometimes there's a DLL like in the application, right? This is sort of the root of DLL hell, right? So DLL hell is when you have two different applications that want to use the same name, but they really want to reference different resources. So you have your version of MFC, I have my version of MFC. We both want to put them in System 32. When I run, I expect to see my version of MFC. When you run, you expect to see your version of MFC. If that doesn't happen, if that's not the case, then one of the two applications is likely to be unhappy. With AppV, that doesn't happen. So when the application is looking in System 32 and saying, hey, I want to get my mfc.dll, the AppV layer is sitting there, it catches the request, and it says, oh, they're looking for this particular name. But we know something. We know that the application installed that resource, and it's basically off in a different location. Underneath the covers, we do some redirection, some virtualization, or as I like to call it, lying, right? We lie to the application. We tell it, yeah, sure, here's your file, and just where you expected it to be. And as far as the application's concerned, it sees the file that it installed, it can access it, it runs, it all works. There's obviously a lot of complexity there, but that's the basic idea. So, if you start to virtualize your applications and start testing them virtually, these are some of the things you're going to have to think about. The system as you see it when you're not inside the application, that view of the world is not the same view that the application has when it's running. And so you start running into these situations where if you want to see what the application's seeing, well, you have to run something inside the virtual environment. And that's actually fully possible. We make that possible. You can run a command prompt inside the virtual environment. You can run regedit inside the virtual environment. You can run any of your testing tools or any of those kind of things inside the virtual environment. And now when you use that tool, you'll see the correct view of the world. You'll see what the application's seeing, and you'll get what you expect. So that's just a tip, because my expectation is that most people, I'll say my hope. My hope is that most of you see this presentation, see the demo, see what we can do, and you're intrigued enough to go and actually give it a try. And if you go virtualize your applications, I'm sure you're going to want to start figuring out what's going on under the covers. And these are some of the techniques you're going to use to do that. So I have one slide on here on request processing, because it is sort of like the key thing that that ties together all these different ideas that we're talking about. We're talking about virtualization. We're talking about isolation. And isolation means keeping that stuff out of the operating system, not allowing the application to change the operating system. We refer to that as isolation. We also talked about something called state separation. And state separation is a little bit different than isolation. And sometimes it's, sometimes they're two very related concepts, but it can get confusing. Isolation is all about when the application installs and it tries to change the system resources. We prevent that, we virtualize, we isolate, great. State separation is actually slightly different. State separation is a runtime concept. So when the application's running, it goes off and tries to make all kinds of changes to resources. Sometimes they're user-specific resources. sometimes they're machine-specific resources. In those cases, AppV, that virtualization layer, honestly doesn't allow those things to directly happen. What I mean by that is, if let's say your application goes and changes a registry key that you had originally installed, we don't allow that request to go through, and we don't allow that original registry key to get edited. Instead, what we do is we separate the state, and we basically have a separate namespace where we store that change, and we keep that separate. And what that allows us to do is ensure that that original image that you sequenced and that you put up on the server and that got deployed out to all those machines, when it makes it down to the AppV client, that image never changes. We call it an immutable image or a golden image. The reason that we do that is you may have lots of users running on a particular machine. For example, a terminal server. And a big problem with terminal server applications is user A may do something, and then user B is affected. And those effects are rarely the intent, right? Normally what's happening is the application is changing a resource that the change is really user-specific, but it's in sort of a shared location. And what AppV does is, on a per-user basis, we take all of those changes that are made. We don't allow them to be made to the golden image. Instead, we store them in a separate location in the user's profile where the changes for that user are stored. What that does is, it means that if, let's say, the application has a problem. How many people have ever used an application one day and it was working fine? You're using it the next day, something happens, and all of a sudden the app stops working. Like, Office is a great example of that. Normally what they'll tell you is, well, run a repair. And a repair in the MSI world is running a whole bunch more code to go off and change your system even more in the hopes that it undoes whatever was done before and whatever happened. And the numbers that I've heard of the success rate of repair actually doing something good is fairly low. We have a very different model, and it doesn't rely on any code being written by the ISV or anything like that. Our model is we have the bits pristine as they looked when they were installed. And we have all the changes over here. And actually, all the changes are stored in a single file, and it's like a file system to file kind of thing that we do. And so if the application goes haywire, breaks itself, or anything happens and it stops working, we can get you back to golden in an eighth of a second, because all we have to do is delete one file. You delete that one file, you relaunch the application, and it's like you just installed it from scratch. And so that is something that's really kind of an interesting side effect of all of this virtualization. That ability to be able to reset the system back to, or reset not the system, but just that application back to the state that it was before. And all of your other settings, like for other applications, like for me, I have somewhere in the order of 300 and something virtual applications on my laptop. Those settings are all separate. So if I have to reset Visual Studio 2005, I don't lose my Visual Studio 2008 settings, right? Because the 2005 settings are over here, the 2008 settings are over there, and so there's no chance of one sort of fixing one, fixing the other. So one thing I wanted to sort of point out here is I put it as logical namespace processing because it's not always the case that the processing works this way, but this is kind of the general flow of things. When we're looking up a resource, we first go and check and see if the user has edited it, right? Because if they have edited it, then that means that's typically the one that wants to be returned. Not always the case. There's security policies that you may not want users to be able to override certain things. But in general, if the application has made any changes to any resources, and that resource has been copy unwritten, that's typically where we'll go and get that resource from. Then, if the resource isn't there, then we go and look in the resources that were originally sequenced for that application and see if they are there. And if they're not there, then we go off and allow them, we go off and let the local system handle the request. We still get involved in the request for those kind of things so that if the user later changes that resource, like a registry key, we don't allow the local system to be edited. We still copy and write those changes and keep them separate from the system. another type of state separation that we do. And so this really is sort of the key thing that you have to understand if you're going to virtualize your applications and then go and test them and figure out what's going on, is that there are these different places that resources can live, and that virtual environment, the view that you see inside the virtual environment, is actually a composed view. It's made up of, the local system plus the application as it was sequenced plus the, whatever settings the user has made. One interesting thing is we have to do things like what we call persisted delete, which means, let's say the application installed some registry key, right? At installation time, created some registry key. And then don't be shocked if you're inside the virtual environment and you look and you don't see the registry key. What may have happened is either the code or the user or someone inside the virtual environment may have deleted that key. And since we don't edit that golden image, we basically put an entry inside the user settings that say, just remember, this key was deleted. So later on, if someone tries to query for it, they won't see it anymore. If they enumerate the registry, they won't see it anymore. So if you're ever looking around and saying, I know that key was installed, and I know it was there before, and I don't see it anymore, it's likely because something has deleted it at runtime. All right, so how do you develop virtualization-friendly apps? Because we get this question a lot, and there really isn't much to it. Most applications just work. We do a damn good job of virtualizing the OS resources in such a way that the app really can't tell the difference whether it's virtualized or not. There are certain things that will make an enterprise user's life easier if you do, and there are some things that we just don't support. The first category are things like reducing installation assumptions. So there are lots of applications that when you run the installer, they say, oh, look, I'm running on Vista. So therefore, I'm going to lay down these components. Oh, I'm running on XP. I'm going to lay down these components. If your installer does that, then you may have some problems moving forward. And not just with AppV, by the way. A lot of these best practices aren't directly related to app virtualization. They're really just best practices that ISVs should be using for their applications anyway. With AppV, we tell our customers that if you want to support multiple OS versions, you should sequence it on the lowest common denominator OS. Meaning if you need to both support XP and Vista, you should sequence it on XP and then deploy it and run it on XP and Vista. And that usually works. What it looks like to an application, by the way, a virtual application, if you sequence on XP and then you run it on Vista, what it really looks like is you installed it on XP and then you upgraded your operating system to Vista afterwards. And there are lots of applications, including some Microsoft ones, that sort of violate this premise. A great example is Office. So Office has .NET integration in it, right? So you can use all these .NET components that are really great. When you install Office 2007, the installer looks and says, is .NET there? And if it doesn't see .NET, then it doesn't install the .NET components. Of course, if 10 minutes later you install .NET, now you're in a situation where you have a machine that has .NET, it has Office, but there's no .NET integration. And those are bad assumptions to make, right? Just because the state of the world looks one way when you install an application, it doesn't mean that it's never going to change. Another great example is localization, right? Yes, when I'm sequencing the application, I may be doing it on an English operating system. But that doesn't mean that my entire enterprise is all English, right? There may be lots of different languages that we want to run on. So you as an ISV should give the option to install all the different languages when they do an installation and not just default to only the language that the particular version of the operating system that the installation is happening on is. So if I'm installing on English, I should at least have the option to lay down all the other language packs if I'd like to. Other good things to avoid are things like hard-coded paths. We see lots and lots and lots of applications, including Microsoft applications sometimes do it, where you run the install, and on that machine, the system drive is C. And the program files directory is C:\program files. And so the installer, as it's laying down all its resources, it just starts writing these paths directly into the registry, assuming, yeah, that could never change, right? Well, in a virtual world, those things can change. Luckily, AppV does a really good job of fixing this problem. We have something under the covers that detects those situations, and it basically genericizes the image, and then later it fixes it back up. So if this machine has a system drive of M, we'll go through and fix all that up. But that fix-up doesn't come for free. It slows down the launch of the application because we have to do that fix-up when the app launches. If you use things like regexpand string instead, then you won't pay that penalty because the Windows operating system can give you those capabilities and be more dynamic about those things and not have to rely on AppV to do it for you. Next, a category is something that we don't handle today. We do not handle drivers. So I said before that virtualization is all about lying. It's true. It is. It's really all about lying. We lie to the applications. And lying to user mode applications typically isn't a bad thing. We've been doing it for years. I've been working on AppV for over 6 years, and normally good things come of it. Unfortunately, things like drivers are not the kind of software you probably want to lie to, because drivers make very specific assumptions about the state of the system, and if the state of the system is in any way different than the driver assumes, bad things could happen. And so we've taken the approach that we said we're just not going to virtualize drivers. It's just not something that's good for our customers. It's not safe. And so we still sort of take that line. A great thing you can do for your customers is provide a separate installer for your driver. Now, this really isn't something specific to AppV. Our customers tell us that if they have an application that has a driver, they go off and use tools today, if it doesn't have its own installer, to extract the driver. The number one reason being is with most enterprises, they have different groups. They have a platform group. The platform group owns the operating system. They own the hardware drivers, all those kind of things. And then you have the app groups. The app groups are the ones that own the applications. If an application has a device driver in it, typically the app group has to extract it, send it over to the platform group for them to validate that it's compatible with their hardware, and even if it's a software driver and it's not something that tries to make any hardware decisions or dependencies or anything, those things can still sort of happen. And so the platform group likes to take the drivers, test it in their images, validate them, and actually bake them in the images and deploy them out that way. And so whether it's AppV or not, it's always a good thing to do. If your application has a driver, make sure you have a separate INF file or installer or something so that those things can be separated out. Some more things. Right now, when I was speaking before about genericizing things like C:\program files, today we do that for things like the registry. We do not go through and scan all of the files that are part of the application to figure out if those paths exist anywhere else. So if you take an installation time, you put hard-coded paths in INI files or config files or anything like that, then you're going to run into problems if the machine that it gets run on is different in any way than the machine that it was sequenced on. So for example, if, again, come back to the system drive was C, now it's M, those paths won't match up anymore, and AppV today doesn't do anything about that. That's typically not a good thing to do anyway, but with AppV you especially want to avoid it and try to just detect those things at runtime. You can normally query to figure out what the install directory is for something, and you're better off using those kind of techniques in your applications anyway. Another thing we've seen that is just falls under the category of cleanliness of writing your applications is the registry is supposed to be a configuration store, right? Internally in NT, it's the config manager. We see some applications that try to use it as an inter-process communication mechanism. They try to use it as a job queuing mechanism. And in reality, yeah, you could probably use the registry for all kinds of different things. But it wasn't intended for those purposes. And it can get you in a lot of trouble, especially now with Vista, where your users typically are not running elevated when they're running your application. There are lots of applications, including some pretty major ones from some pretty large ISVs, that tried to use the registry as a job queue for print jobs. And it worked great right up until Vista shipped, and people weren't admin anymore, at least when they were typically running, and then the app started blowing up. It's really not the purpose of the registry. There are much better design patterns out there to use, and you should really use something that's more fit for that purpose than trying to overload the registry for doing that. Another thing that enterprises are really adamant about, and something that helps AppV, is being able to disable auto updates. Remember before I was talking about how many people have ran the experiment where you install something or update something and it blows up your system? How much more frustrating is it when the application goes off and does it on your own without your knowledge, right? So my machine was working yesterday. I didn't know it, but some ISV released some update. Without telling me, it went off and sucked down some update, installed it on my system, and it just broke my machine. Enterprises typically turn that off any way that they can. I've even seen them go as far as block outgoing ports on firewalls purely just to stop the fact that the application was trying to phone home to figure out if it could update. I'm not saying that auto update's always bad. I mean, for some consumer scenarios and stuff, some people sort of appreciate that. Just keep it up to date and don't tell me about it. But just make sure that you have a way for your customers to turn that off if they so choose. One big thing a feature of MSI that we just do not support falls pretty much in the same category, and that's install and first use. I always found install and first use is pretty funny, because I would never imagine that clicking on like a menu item, like file and clicking on some menu item could all of a sudden completely change the state of my operating system. It could lay down DLLs in System 32 and do all kinds of stuff. Those are the kind of things that typically your customers are going to want to do in a controlled manner, and not just wait for ad hoc times when the user's doing something to all of a sudden go and change their system. And because of that, we tell our ISVs, just make sure that you don't require it. Now, very, very few people or very few products I've ever seen require install and first use. But sometimes, in order to make the installer simple, they hide those things, but underneath the covers, they're really using install and first use. And it's something that isn't likely to work in an AppV world. Last thing I put out there is just there are some resources that we currently don't virtualize, like shell extensions and WMI and COM+. We're always looking at adding to the things that we virtualize. The hard part that we always face is we have what I call our Hippocratic Oath. So our first rule is do no harm. If we can do it safely, we can feel good about the fact that we can virtualize the subsystem and protect the system and make the application work, then we do it. When you start getting into things like shell extensions, where you're taking your code and you're running it inside a system process, granted it's only the UI, but to the user that is the machine, that's their view of the world. Those are the kind of things that we haven't virtualized yet. We're getting to them, and it ends up being a pretty hard problem to solve, where you want to do it in such a way that you want it to be safe. You don't want to ever harm the system, but you want that integration to happen. We haven't gotten there yet in the current shipping version. So if you have shell extensions, if you virtualize the application, then they're not going to appear. Debugging. The funny part about debugging is there's really not a lot to debugging a virtual app. Pretty much all the standard things tend to work. You can attach a debugger to it. You can use image file execution options. You can run the debugger inside the virtual environment or outside the virtual environment. So I'm not going to get too much into it, but there are some subtle differences. And one of the biggest one is the view that the virtual application has, and I was saying this before, is not the same as the view on your local system. And I'll show you in a minute what I mean when I do a demo. But that's probably the biggest hurdle to get over, is that a lot of times people will just pop open regedit and go and try to look for something. If you just pop open regedit and the app's virtual, you're not going to see the things you expect to see if the app was installed. One great thing that we did with this release is we integrated with Process Monitor. So how many people here have used Process Monitor before? Great. That's exactly what I was hoping to see. The interesting thing about AppV is we do such a good job of virtualizing that sometimes we can even hide from Process Monitor. Not always, but in some cases. So what we did was we built integration with Process Monitor so that we take all of the same events that it would normally track on the local system, and when it's dealing with virtual resources, we inject them into the Process Monitor log. So you can use Process Monitor just like you always did in the past. The one little trick to it is there's a flag you have to specify to turn on the integration. And the integration only exists in Process Mon 1.6 or later, which I think it's up to 2.0 now, so I assume people are on probably a pretty recent version. That flag is external capture, and I'll demonstrate that quickly in a minute to show you what it's like. Another great tool that we find we use a lot internally is Process Monitor. One reason that we like to use Process Monitor is sometimes we just want to figure out, is this app inside a virtual environment or not? And usually purely by looking at the parent-child relationship in Process Monitor, you can see very quickly that, oh, this command prompt was spawned by this application, which is a virtual application. And once an application is virtual, all of its children are virtual, all the child processes are virtual. And so it's kind of a nice, quick and dirty way of just looking and seeing if something's inside or outside the virtual environment. That's pretty much it. I mean, I've been debugging virtual applications for years, and I didn't really have to learn too much to get it working. So, and I think, all right. So I've got a few minutes left before I turn it over to Alvin, and I'm going to do a couple of quick little demos. I'm going to put Office back on the machine since I did pull it off before. So what I'm going to do is I'm going to put Office on here, and while that's happening, I'm going to go and take regedit. And if I go and look at my local registry, you'll see that so if you look in here, I have some keys lying around from probably from some random application. The Outlook search toolbar. Oh, that's right. Those are part of Windows. I forgot. So yeah, as you can see, if I open up the local registry right now, I don't see Office, right? So all the keys, Office has a lot of keys. It has somewhere in the order of like 15 megs of keys that it puts in the registry. Those aren't here because Office isn't installed on this machine. So if I was going to go and debug Word, I wouldn't be able to just go and do that. So here's an example of me launching Word. And if I go and look around inside of Word, for example, if I go and look I can go around here, and inside of the virtual environment, I can go and see all of the things that make up Office. So, for example, if I go and look under Program Files, Common Files, Common Files is a place that Office puts an awful lot of files under Microsoft Shared. So if I look in here, I see a ton of stuff that Office laid down. Like, great example is the equation editor I mentioned before, right? Here's the equation editor, is that the right one? Yeah. But if I go and look at my local system, I'm not going to see all of those same. I'm not going to see all those same files under Common Files. And the reason I'm not going to be able to see them is because they're not really there, right? The virtualization layer is lying to my application, and it's telling me. So yeah, so equation editor is not there. A bunch of other stuff isn't there. So inside the virtual environment, the list is very long because that's all stuff that Office has put in there. Outside the virtual environment, this is really just a vanilla install of Vista. I don't install anything on my machine. So really only the things that came with Vista should I expect to see in there. So there's one example of the kinds of things that the differences you'll see between the virtual world and the native world. If you want, I can go and show you regedit, for example. One key thing that I did here, by the way, is I launched Word elevated because I want to launch regedit. One thing that we handle in AppV is if you originally launch the application elevated, the elevation works fine. If it tries to elevate while a virtual application tries to launch another app that elevates, that app is not going to be inside the virtual environment. And it's actually something we do for security reasons right now. We don't want to be able to do is allow this virtual environment to sort of automatically start lying to an application that's elevated. If the user takes the action and elevates on their own and they know what they're doing, that's fine. But if the application behind the scenes just launches something, then we don't typically want that to be inside the virtual environment. And so what I'll do here is I will launch regedit from inside the virtual environment. And there are like 500 different ways you could launch an application. I tend to like this particular way. Now, I'm inside the virtual environment. And so now if I go and look at the same key that I was looking at before, now all of a sudden you see all the things you're used to seeing when Office is installed. These are all those keys that are inside the virtual environment but not on the local system. So that's just kind of a feel of the sort of things that you'll see when debugging. I was going to show you, does everyone know image file execution options? It's a great way to sort of catch the startup of an application and get the debugger in there right at the beginning. I don't think you need to see that. And procmon looks the same whether you're using the /external capture or not. So I don't think we really need to get into that. So with that, I'm going to turn it over to Alvin, and he's going to talk about testing virtual applications.
Thank you, John. So how are we doing so far? Feeling good? Good. So customers. It's all about the customers. Customers love functionality. They love new features. They love actually, do you have the clicker? Oh, here we go. Cool. They love functionality. They love new features. But what really gets their blood boiling is bad quality. In Microsoft, we're all about quality. So we wanted to spend a few minutes talking about testing. So John showed you how virtualization works, showed you a little bit about the internals, but aren't you wondering, how do we test these things? How do we test virtual apps? The simple answer is that you test it the exact same way as you would test your native applications. If your existing test investment drives your application through the graphical user interface, well, the GUI works the exact same way in a virtual application that it will do in a native application. So you wouldn't need to do any changes there. If you have an approach based more on engine-level testing or strict component-based testing, then as John showed you, you can launch any applications inside a virtual environment, which would enable your test collateral to access COM objects through the registry. You have other options. The processes, John didn't get to do his debugging demo, but processes will show up in the system running process list. COM objects get registered in the system running object tables, so you don't even need to be inside the virtual environment to access these things from a testing perspective. And going back to your UI-based testing, file types associations are there, shortcuts are there. You can access all those things and drive the UI and test your application. But the non-simple answer, and I'm hoping your test instincts are kicking in on this, is that you don't want to do only the testing that you would do a native application. The virtualization aspects of an application actually open up a new range of testing areas that you should cover. I wanted to name a few. This is not a complete list. This is just a few things to consider. But basically, platform compatibility is a big one. Like, for example, we were talking about sequencing applications in Vista versus XP. If, for example, you sequence an application in XP and you run it on Vista, it's likely that everything that it needs is going to be there. But if you do the inverse of that and you sequence an application in Vista and you try to run it in XP, it might be that your installer made some assumptions about the binaries that the application was laying down at installation that are in Vista but are not likely to be in XP. So platform compatibility is one of the big things to keep in mind when testing virtual apps. And remember, sequence means the art of virtualization something. Default file locations, it's also one thing to consider. As we were talking about earlier, virtual applications will have a virtual file system in which they lay down all the files that they need at installation. And as John mentioned, these files can change when new binaries are streamed down from the servers to the users when they're launching applications. If your applications, for example, store user-specific files inside system directories at installation time, this may be overwritten during the application's lifetime. Or, for example, when we're talking about reverting an application to its golden state, these things get wiped out. So applications really have to be a little bit friendlier to the Windows model and store their user-specific data inside the user profile directories. Another point that I wanted to briefly touch on is internal testing. And John talked a little bit about this, where it's kind of hard for us as developers to commit to testing pre-release versions of products in your developer machines. I mean, it's all nice and good. You get to play around with the new features. But for example, in scenarios in which you have older released versions of the product in your machines, this can cause problems. So you know that there's an assumed risk. An example that I wanted to share with you guys is that before joining the application virtualization team, I used to work in Visual Studio, particularly Visual C++. Now, as it is with most pre-release software, there is a risk involved with installation and uninstallation. It can be very buggy. And as you know, Visual Studio is a pretty complex application. Visual Studio will lay down C runtime libraries, MFC, ATL, and all these things will be versioned. So if you consider internal deployments of Visual Studio, internal builds, this will be versioned daily, and also .NET. So you can see how it can become a little bit difficult for a developer to internal test new versions of Visual Studio. Well, these are problems that application virtualization can solve, because they provide an unobtrusive way for you to deploy in your machine pre-release versions of your applications, and you can easily undo what they did by just right-clicking, deleting a file, and that's it. There's no uninstallation needed, which is a really cool thing. Now, before we move on, if there's one thing that I'd like to project with this slide, I would like to emphasize that companies are doing application virtualization. Companies are taking your applications and they're virtualizing them. So in order to provide a very positive user experience for your customers, testing is of the utmost importance. OK, we're almost done here. So what should you take with you out of this presentation? Well, we'd like you to embrace a life without installations, a life without uninstallations. I know I could use one. We would like for you to try out our binaries. They're on MSDN. If you would like to take the time to talk with us and learn more about our product, we're going to be here all week. We're going to be sharing the virtualization booth with the OS virtualization guys. You can also send us an email if you'd like to set some time apart. Here's a few links for you to get on MSDN, learn more about our product. And before we move to the Q&A, I'd like to remind you guys to fill up our evaluations. We appreciate it. We want you to make us better. And without further ado, Q&A. Thank you for coming. Q&A slide.
No, I was going to say
Keep it in the links.
there we go.
Yeah.
Leave that one up there for you guys. All right, so if anyone has questions, can you please go to the microphones
Use the
because it's being
microphones.
recorded? So,
Well, there are also applications like Office that's remembering the username of the user who installed it. Are there any tricks on solving that issue?
yeah, so we actually handle that today. What we do is when you run the installer on the sequencing station, we actually know the name of the user that's running the install. And that when I talked about genericizing the image, we go through the data. If we find that username in there, we put in a token saying, it's sort of like insert current username here. And then when each user launches the application, that user's username will get filled in there. We do the same things for the user's SID, for the machine name, for a whole bunch of different sort of standard things that that are done at installation time. We do the best that we can. As I said before, if you took that username and then you stuck it in an INI file or something, we wouldn't capture that. At the end of the day, installation is not a user-specific operation, and you as an ISV should never treat it as a user-specific operation. It's a machine-specific operation. It's laying down the bits on that particular machine. You may have 500 users all log onto that machine and use that piece of software, and so you should really sort of think about that when you're building your installers and doing your app design. Does that make sense? Okay.
I'm curious, when are you guys going to support 64-bit Windows clients? Currently, I understand you only support 32-bit clients, and it's kind of frustrating for us who develop for both environments.
Yep. That is part of our, we understand the urgency there, so we have taken our next release that was going to be a much larger release. We've scoped it way down pretty much to be 64-bit. And we're doing that, and I don't think we have a POR date yet, but we're doing just the porting work, and then we're going to ship it. And so you should be coming soon to a store near you.
All right, with the virtualization being a software as a service, how does that impact the Click-Once technologies?
It doesn't impact the Click-Once technologies. It's really a choice. If your application is simple enough to be able to run on Click-Once, then you could choose to use Click-Once. What we found typically is that most applications are too complicated to run a Click-Once. If you're going to build a Click-Once application, you normally start from scratch and build a Click-Once application. And you don't do anything that's not supported by Click-Once. If you've already built a Click-Once application and you're happy with Click-Once, then you could stick with it. We have had people very unhappy with Click-Once and have decided to use AppV. They've virtualized the Click-Once applications, then use AppV to deploy them. And that is something that you can do if you want to do. We are broad. We can handle any Win32 app and any Windows application, whereas Click-Once is really targeted just to a specific type of application. That's really the difference.
Two quick questions. The first one being, does AppV break licensing and activation models that we're currently using right now?
Yes, in some ways it does. Mostly the licensing issue is the big one that people run into. People usually assume that at installation time they can just lay down a license. AppV doesn't do anything to get around the licensing, meaning that if the application has sort of tattoos in the machine with a particular machine-specific identifier, then that application is going to run into problems. What enterprise customers tend to do is they tend to work with the ISV to get a volume license, like they do with Microsoft, and AppV allows them to track the usage. In other words, we have metering data, and we actually also have a licensing functionality, but the one that most people use is the metering functionality to track how many people are using my applications to make sure that they're paying the ISV for all the versions that they're using. So,
right. I think it's interesting that this is a developers conference and that I didn't expect this session to be here at a developers conference. So this being a developers conference, are you expecting software vendors to be delivering their software as a virtual app?
So there's been a lot of talk about that, and we don't have any plan of record right now. But we love to hear from, we've heard from lots of ISVs that have come and spoken to us and talked about the kinds of requirements that they have. So if you have any ideas or anything like that, feel free to send it to the alias that we had up on the screen and let us know what you think. But we don't have any plans to do that right now.
You mentioned earlier that AppV currently doesn't support virtualizing COM+. If your application still has to interface with existing COM+ objects, can you do what you suggested with drivers and have a separate install for that and then execute it?
Yep, that works fine. So if you do that, typically what we found is most of the client applications, they talk to COM+ applications as opposed to being a COM+ application. And so it hasn't been that big of an issue so far. We're still working on it anyway because we figure, in our mind, the more subsystems we can check off, the higher the app compat will be. But yeah, you're right. In most cases, anything that's not supported, you can just have a separate installer, and like you do for drivers, and that will work. Yes.
Thank you for great demos and good explanations. I really like that all. My question is, how do you see your division fit into the company's cloud computing vision right now?
Sorry, could you repeat that?
How do you see your division fit into Microsoft's cloud computing vision right now?
We're not sure yet. So I mean, the cloud computing vision is very new. The model right now with cloud computing is very much cloud-centric. And what we see is we think we bring an interesting aspect to that to the picture, where you can take your regular applications, and rather than having to rewrite them, I'm amazed by some of the like press releases I've seen where some very large ISVs are talking about spending 10 years rewriting their application so that it'll run on the web. In 10 years from now, they'll have the exact same feature set they have today, and they think that's a good thing. And in my mind, I figure you already have that feature set. Why wouldn't you spend the next 10 years adding new features to add value to your customers, and not spend that time, because whatever technology you pick, 10 years from now, it's probably going to be obsolete. The rate at which technologies happen.
And I have a follow-up question. Do you see your streaming protocol sometime working over the internet?
It does now. We support HTTP.
But
a lot of our
people using over internet connections.
Excuse me?
People using it over the internet, not in internet scenarios.
Yeah, no. We have customers doing that today. Absolutely, no. We have customers today that they have either a very small site, or they have individual users in the field, and they get their applications over the internet. Yep, absolutely.
Thank you.
If the application is built on top of SQL Server and has to be on the same node, will that work?
So right now, for client application, because right now we only target the desktop, not server apps, and so in that scenario right now, we have virtualized SQL Server internally, and we get it to work, and that's fine and all. But typically, we tell customers not to virtualize SQL. And so in that case, you'd want to locally install SQL, which would kind of be a bummer.
Right. One more question. Do you have app compatibility tools to check a client application?
So we don't have a lot right now. We're working on it, and there are third parties that have tools that do exactly that for AppV. And so currently, when customers come to us with those requests, we normally send them to a partner. But we are looking at doing a lot internally as well.
Thanks.
Hi, I've got a situation where we install multiple versions of our products side by side to deal with older versions of devices they deal with. But at the same time, we'd like the user's configuration and settings to be shared across those side-by-side versions. Thought I heard it probably wouldn't work that way in the virtualization engine. They'd all have separate ones?
In that scenario, they would have separate. Well, some of it depends on where you store your config. And there's a lot of flexibility inside of AppV around which resources are virtualized and which ones are not. And so you could actually configure AppV to get them to share. You could also decide to have those settings be local on the machine instead of virtualized. And we have those policies inside of AppV. It's not something we typically see enterprises use, but it is possible.
Does it make that decision on individual applications, or if they were all installed as one in virtual install, would it appear like one application?
Oh no, it's not per application. It's like you said. It's per what we call package or image or suite. So yes, if you put them all into the same package, they would definitely share all the same stuff.
Thank you.
Maybe two quick questions. One is, how would you deploy a fix? Would you have to recreate an image and deploy the entire image?
Sorry, could you say that again?
To deploy a fix, like a hotfix or a patch or whatever?
Yeah. No, all you do is you open up the package in the sequencer, apply the fix, hit save. And we didn't really get into it, but the way that the streaming technology works, we will only bring down the bits that have changed. And so that's before we were talking about always staying up to date, that's what customers love about it. They can make that one change, they can test it, make sure it's good, they put it up on the central server, and then just the difference gets streamed down.
And one question with regards to the GAC, is the application isolated, I'm not sure if it's the right word, but from the GAC on the machine, on the client PC, or will it access what version of the GAC will it see? Like its own?
Well, so if it puts things in the GAC, then it will see those, that will work, right? So that works today. And what it sees is a merge between what's in, what it installed and what's in the local GAC. Okay. So it's just like, for any of the things that are on the local system, it's just like the apps installed.
Yeah, because we've seen that problem with ClickOnce where we don't do assembly versioning for some of the DLLs, and when we get on the client PC, if one of the DLL there has the same assembly version, it will pick up from the local GAC, and it's not isolated as much as we'd like.
With AppV, it would see the virtual one.
The virtual one.
So how does this work with several applications that work together? Say I wanted to install Visual Studio, and then I wanted to install a plugin like CodeRush. Do I have to go back and make a new gold image and bring those down as a set?
You used to have to, yes, but now in 4.5 we have something that, and by the way, our marketing team the marketing at Microsoft is astounding with the names we come up with. It is called Dynamic Suite Composition, because that was just long enough to be confusing. What it really means is that you can take different golden images and you can have them compose on the fly. So a great use case that we see customers doing now is they would virtualize, for example, in your case, you virtualize Visual Studio. You have core Visual Studio. And you virtualize all the separate plugins that you have. And what you can do is centrally you can manage which users have access to which plugins. And dynamically, when the user launches the application, AppV detects which one of the plugins it has access to, and those are the only ones that that user sees. So you could actually have two different users running on the same machine, and they could have a different set of plugins based purely on the permissions that are controlled centrally.
So would that work in a scenario like Visual Studio for Office? So if I have one virtualization for Office and a different virtualization for Visual Studio, and to have this work, it needs to be aware of Office being on the machine.
So today, it does work, but we discourage people from doing it. We will remove that caveat in the future. What we typically tell people is that we built the feature around two use cases, the plugin case and middleware. Because another great one is middleware. People will say, oh, I want to virtualize the Java runtime. And then I want to virtualize 50 Java apps. And I want them all to share, well, I want these 25 to use this version of the Java runtime, and I want these 25 to use that version of the Java runtime. But I don't want to sequence the Java runtime 50 times. And so we built it for those cases, and for the plugin cases, when you have two large applications, and large really is around the number of resources. Technically, it's around the number of registry keys, and not the number of files, but the number of files that magically appear in well-known locations. The app launch can start to get slow in those scenarios. The other downside is that the settings between the two different applications get intertwined, right? With plugins and middleware, who cares, right? Actually, with middleware, the middleware stays pristine, and each application has their own settings. With plugins, any changes to the registry or anything that the plugin made would end up being, saved with the application that's plugging into. So that's really not that big of a deal. But now if you're talking about your Office settings, your Visual Studio settings, now all those get intertwined, and it's non-ideal. We have a solution to the problem, we haven't implemented and shipped it yet.
Thanks.
Details.
Yes, when you're in a situation where you have multiple applications, if they're all virtual, can they address each other? Can you via IP address or
talk to each other?
Yeah. Can you see the app if it's virtual?
So it depends on how they're trying to see each other. IP address, those kind of things will all work. If they're trying to look at each other's registry, those kind of things will not work. Right. And so typically, we just set people's expectations that they won't see each other. But then we have customers say, yeah, but I have these two and they're working fine. And we say, well, that's one of the exceptional cases that happens to work. In general, the answer is, isolation really means that they're separate, and so they typically won't see each other.
Okay, thank you.
Excellent presentation, thank you. Can I expect things like drag and drop to work normally between apps?
Well, drag and drop works normally with the exception of the case where if you're dragging something that really represents a COM object that's virtualized inside this virtual environment, and you drop it over on an application that doesn't see that virtual COM object over here. So if you're spanning two bubbles or something like that, those kind of things. In a lot of cases, actually, drag and drop in Olay does some pretty cool things. Like, I've done that before, and yeah, it doesn't see the COM object anymore, but instead it shows me like the image of it, and so it actually does what I wanted anyway. But in general, yeah, drag and drop typically works fine.
Okay. And the cost of the product?
It's $7 per seat on top of SA. It's part of MDOP.
Okay.
So.
In our case, the installer puts some specific information in a config file. And I'm wondering how we might go about addressing that. Ideally, there would be one image for every PC, even though each PC has a separate, unique config file.
Yep. So there's a couple of things you can do. We actually have a couple of scripting points inside the application, and our customers love this because it's the big red lever, right? Because they said, you know what, we can say on launch, you can run this script as the app launches, and then a really popular one that people do is they say, well, each one of my sites are on the globe. We store the config file centrally anyway on a file share, and then it just copies it down when the user launches it, and there, I scripted around the problem, and in a single one line of scripting or whatever. So that's the typical solution that we see people use. We have slightly more elegant ones as well, like inside the application descriptor, the thing that sort of describes the application that's being launched. You can specify registry keys that take their values from environment variables, and there's all different kinds of things that you can use. The scripting one is the typical one that we see people use.
Thank you. Thank you very much.
You're welcome. Is that it?